So now we will have a discussion on optical instrument, and the first thing is your microscope. Now we know microscope are used to view small objects. So what is the basic setting of microscope? Now what we do is, say suppose this is your lens. Now we bring our eye close to the lens. This is our eye. We bring this close to the lens, and what we do is we put this the object in the focal length or near the focal length. Say suppose this is your object which is very small. This is very small. Very small. So now what happens, because of this we know a line which is traveling, say suppose this point, this height. This point will be going over here, and this height, say a line is traveling over here. So a line which travels parallel to the principal axis always passes through the focus. So it's passing through the focus. Say this is my eye. In other way, a line, say, now for the timing let's rub this eye. For the timing let's just trace the image. So this is going somewhere over here. So focus is somewhere over here. And another line which passes through the pole will straight away go to the pole. This is what is happening. So if I trace back, please pardon my drawing. Okay. So now if I trace back, this will pass through the focus. So if I trace back, what I will see is this. I'll see that the object is formed maybe at infinity. Maybe at infinity, and it is very large and it's a huge one. This is the object. So for very small objects we see that the image is a huge one, and therefore this is what it is doing, it's magnifying. So this is the working of a telescope. This is the basic theory of a telescope. Now what we have to do is we have to keep the object at focus or just near the focus, but we know the most comfortable that our eyes are able to see is at d equals to 25 centimeter. So somewhere beyond this point, if we keep our object, we'll have a comfortable magnified object that we can observe. So now let the distance, the object, that is the object distance be say u. We know this is the object distance, and let the image distance, let the perceived image distance, because we know this will never meet, it will keep on going. So if we put our eye over here, because of our eye which also behaves as an optical instrument as we have discussed, it will meet behind our retina and it will form an image. So now let this distance, the perceived image distance, be d. So now we know magnification. If we go to the mathematical part, magnification is actually equal to V upon U, which is nothing but, if you take V common, this is 1 by V minus 1 by F. What is U? U is 1 by V minus 1 by F, which is again equal to 1 minus V by F. So this is a derivation that we can have. 1 by V plus 1 by U is equal to 1 by F. Actually, I have put this particular formula over here. So now, what is magnification? If you talk about magnification, is nothing but 1. Now, if you look at over here, what is V? V is this distance, V is distance d, and we are measuring this from over here, this to here, so this will be minus d. 1 minus plus d by f. This is Therefore, magnification m is nothing but this 1 plus minus d by f. Now, if you look at the angle, say suppose this is a height h1 and let this be your height h2. So, if you want the angle, that is magnification, this is nothing but your height. This is h dash upon h, where h dash is the size of the image. This is the size of the image. This h2 is actually h dash. This is the size of the image. Let's name this size of image. And this is size of object. Size of object. So now if you want the angle, if you want tan theta. Now what is tan theta? If you look over here, you are looking at a angle. This particular angle that we are talking about. This particular angle. So because you are looking over here, you have an angle which is over here. So what is this angle that you're looking at? This angle theta, if you look over here with your eye, angle theta is this h and this distance d. This is your distance d and this is your distance h. So you are talking about this angle. The eye which you are looking at. The eye which you are looking at, this particular angle is nothing but your tan theta. Let me change the color. Tan theta, or in your book it's given tan theta naught. So for not to have further confusion, let this be tan theta naught. Let this angle be theta naught. So tan theta naught is actually given by h upon d. This height h and this d, which is approximately equal to theta naught. Why? Because theta is very small. If theta is very small, therefore tan theta is equal to theta, as we have discussed so many times. So now let's take this calculation in our next slide. What we have is h dash minus h is nothing but your m, which is nothing but your v by u. Therefore tan theta, as we have derived earlier, is h dash minus v, which is equal to h minus v into v minus u. V minus u. We can say this, which is again equal to h minus u, which is equal to theta. Therefore u, we know what is u, what is object distance. We, in our previous calculation, we had put this in our focal length, the distance f. Object, we have said that to put it in the focus. So theta is equal to minus f. Sorry, not theta u. The object distance is equal to minus f. So if you put this minus f, this is theta will be equal to, that is theta I. If you're looking at tan theta, that is theta I. Theta I will be equal to h upon f, that is height upon the focal length. So now finally, what is magnification? What is magnification? Is nothing but your theta of incidence upon theta, that is final, which is equal to, if you put all the values in our previous slide, let this be equation b, and in a previous slide there was equation a. So if you take theta 1 upon theta naught, what you have? We had d upon f, and this is our m, where the angular magnification, where m is known as your angular magnification. So this is how we can understand the working of a microscope.